FastAPI relies on Pydantic for all of its data validation, and Pydantic v2 was a major rewrite with a new API and a Rust-powered core. If you have seen Pydantic v1 code, or if you are reading FastAPI docs that reference the old style, this video will make sure you know exactly what changed, what the new pieces are called, and how to use them confidently. In Pydantic version 1, to turn a model into a dictionary you call .dict, and to load one from an ORM object, you call from OM. Custom field validation used the 8validator decorator, but its argument ordering and the way it received already validated sibling fields was frequently surprising. All of that configuration, ORM mode, alias generators, extra field policy, lived inside a nested class called config, which felt disconnected from the rest of Python. And because the validation engine was pure Python, it became a bottleneck in high-throughput services. Think of Pydantic as an intake desk at an office. In version 1, the trays had odd labels, and the clerk followed rules that were hard to look up. Pydantic v2 relabeled everything with obvious names, rewrote the rulebook so custom checks are predictable, and swapped the human clerk for a Rust-powered robot. Your forms, meaning your data, go through the same process, just with a cleaner interface and far greater speed. Pydantic v2 renamed and redesigned 4 core building blocks. First, model validate is now the single method to construct a model from a dict or an ORM object. Second, model dump is how you serialize a model back out, and it accepts useful arguments like exclude and mode. Third, field validator is a decorator for per-field custom logic, and it has explicit before or after semantics, so you always know when it runs relative to Pydantic's own type coercion. Fourth, model validator lets you inspect and modify the whole model at once. Finally, model config is a plain type dict style class attribute that replaces the old nested config class. Starting at the top, we import ConfigDict alongside the new validator decorators. Inside order item, we set model config equal to ConfigDict, passing str strip whitespace equals true, so leading and trailing spaces are removed automatically, and extra equals forbid, so unexpected fields are rejected, rather than silently ignored. The field validator decorator targets the quantity field. It is a class method, receives the raw value, and raises a value error if quantity is 0 or negative. Otherwise, it returns the value unchanged. The model validator with mode equals after runs once all individual fields have already been validated, so we can safely read self.discount and enforce a cross-field business rule. In the root itself, we call item.modelDump and pass exclude equals a set containing discount, so that field is omitted from the serialized output. FastAPI then wraps the resulting dict in a JSON response automatically. When a request arrives, FastAPI passes the JSON body into a plain Python dict and passes it to Pydantic's model validate. Under the hood, Pydantic code, the compiled Rust library, coerces each field to its declared type, then fires any field validators in the order you specified. After all fields pass, model validators marked mode equals after receive the fully assembled model instance. On the way out, model dump with mode equals JSON ensures complex types like datetime objects are serialized to strings rather than raising an error. The practical consequence is validation that is roughly 5 to 10 times faster than v1, with clearer error messages and no hidden magic. Reach for field validator and model validator when you have genuine business rules. A quantity must be positive, 2 dates must be in order, because that logic belongs in the model, not scattered across your route functions. Use model config to enforce a consistent policy across a whole model, like stripping whitespace or forbidding unexpected fields. On the other hand, if a plain type annotation already does the job, adding a validator just adds noise. And never mix version 1 style at validator decorators with version 2 style at field validator in the same project. That inconsistency will confuse every developer who reads the code later. To wrap up, Pydantic v2 renamed its core methods to make their intent obvious: model validate to build a model, model dump to serialize it. Custom logic now lives in 2 well-separated decorators: field validator for single field rules, and model validator for whole model rules. Configuration moves out of a nested class and into a plain ConfigDict assignment. And all of this runs on a compiled Rust core, so your FastAPI app gets faster validation for free the moment you upgrade.